Hello, everyone. This is Leah Freeberg from Fluke Excelix, and thank you for joining us this morning. I'm going to start our presentation in just a few minutes. We're going to wait for more people to log in. So thanks very much, and we'll talk to you soon. Hello, everyone. Thank you so much for joining us today. We have lots of folks on the phone, and I'm going to hold for just another minute so we can have a few more people join, and then we will get our presentation underway. Okie doke. I'm going to kick off with some introductory materials while we wait for everyone to join us. So thanks so much. This is Leah Freeberg from Fluke Excelix, and I appreciate you giving us your time today. You probably know Fluke is a test tool provider, and you may also know that we produce some of the industry's favorite reliability tools, including infrared cameras and vibration meters. But you may not know that many of the measurements that our tools collect now flow automatically into EAM systems of record. It happens via a framework that we call Fluke Excelix, and that's part of why we're doing this webinar series. So the goal is to better connect asset management data into existing asset management systems. And it all turns around best practices in condition-based maintenance. So that's why this webinar series exists. That's why we explore a mix of reliability maintenance strategies, as well as technology, and why we feature speakers from a variety of expert backgrounds, such as today. So before the presentation, we have a couple housekeeping items. This session is being recorded, so your phone lines are muted to minimize background noise. There will be time after the presentation for questions. So to ask a question, find the questions widget, the gray bar next to your presentation window. You can type in a question at any time. At the end of the presentation, there will be time for Q&A. I will read the questions out loud to Dr. Marino, and he will respond. If we run out of time, then we will follow up with the questions afterward. If you'd like to receive the slides from today's presentation, let us know. After the presentation is done, a survey will appear on your screen. Everyone who answers the survey will automatically receive a copy of the slides from today's presentation. Also, at the end of the presentation, you will see contact information for Dr. Marino. If you'd like to follow up with him directly, you are welcome to. All right, now, today we are very pleased to have with us reliability engineer and consultant Dr. Lucas Marino, who will be presenting today's topic, repair and replace resource strategies for your asset lifecycle management. I personally have the greatest respect for military engineers and technicians, being with Luke for so long, and because in particular, I find that their mindset around facility maintenance is exceptional, almost without fail. It has to be. So Lucas is a practicing engineering project manager and educator. He specializes in reliability engineering, logistics engineering, project management, and training systems development. He is currently the Senior Reliability Engineer and Logistics Program Manager at BMT, a multidisciplinary consulting firm that provides engineering and technical services in the maritime and environmental sectors. Lucas served 21 years in the U.S. Coast Guard and is experienced at all levels of the shipboard maintenance chain, from propulsion mechanic to chief engineer. He also served as a port engineer, naval engineering workforce, and policy manager at Coast Guard headquarters, and as a branch chief at the Coast Guard's Engineering and Weapons School. And you'll hear a lot of Coast Guard references as we go through this today, because all of that experience and data is truly revealing. Lucas is also coming out with a book, Asset Management and Level of Repair Analysis 101, which parlays his experience in integrated logistics support into an asset management strategy. There's been a lot of buzz about this book in the reliability community, and I'm really excited to learn more about his approach today. So good morning, Lucas. Thanks for joining us.
Good morning. How are you?
I am fantastic, and I'm just so excited to have this conversation today. How about you forward the slides, because I want to have an opening question.
Okay.
Right there. I want to trigger this poll where everyone can see it. There we go. Because what you are presenting on today is fairly specific, and I'd like to see how many of the folks that are on the line right now are already familiar with some of your topics. So if people on the phone can use their mouse clicks to select as many of these that apply, which of these maintenance analyses are you currently using? Failure mode effect and criticality analysis, level of repair analysis, maintenance allocation chart, maintenance task analysis, or none of the above. Okay, so give that a minute. You're welcome to think about it. While you're answering, I'm going to pitch Lucas a question, because because as I was looking over your bio, I spend time talking with both military, former military, and pure commercial. And given how much of your data set comes from military, I'm curious about how much military asset management strategy applies to regular commercial industry.
That's a fantastic question. They go hand in hand, to be honest with you.
Okay.
You know, as we discussed previously yesterday during a conversation, the Department of Defense in the United States military own probably more assets than anyone else in the world.
Yeah.
So, they have this very unique opportunity to manage assets across so many different types of portfolios, right? And so the facilities they manage, the airborne and waterborne vessels, all of it, when you take it in as totality, really give the different areas of the U.S. military the opportunity to manage assets on such a large scale. And because of that, and they have to be fairly specialized at what they do. Because of that, we get a lot of experience in managing multiple asset portfolios, and we become pretty well practiced at doing that.
Okay, and so you feel like that really does apply to commercial industry, that there are lessons that can transfer over?
Absolutely, because when you look at efficiencies and effectiveness, and we kind of take those as the keys in the military toward achieving mission success. Well, it's the same thing in the commercial sector. right? You need
Yeah.
efficiencies and effectiveness to maximize productivity, um, to maximize your return on your investments, and to make the effort that you put into your business worthwhile. So, yeah, those areas of asset management transfer completely between the military and commercial sectors.
You mentioned a couple things yesterday that really stuck in my mind. You said that the military commonly will take an asset that's meant to last 20 years and extend it to 40 just through
Mhm.
standard practices. But then they also are very practiced at deciding which asset should be maintained to last 40 years and which shouldn't. And I love that there is this logic for decision making in there as well as the logic for maintenance. So
Yeah,
with that, I'm going to close our poll and I'm going to share the results. And this is interesting. Let's let everybody have a chance to read here. So a lot of people are familiar with failure mode effect and criticality analysis because that is kind of one of the roots of reliability and maintenance. And you've got 20% who are familiar with level of repair analysis. That's great. And then maintenance allocation chart and maintenance task analysis is also really high. That's great. That's
excellent.
great. Okay. So I'm now going to hide the poll and you can go back to presentation mode in your slides and you can take it away.
Are you able to see the slide well?
Yes, we can.
Perfectly. All right, well, let's get rocking then.
Okay.
So, if you take a look at the level of repair analysis and take it outside of its traditional kind of preliminary acquisition analysis type of work, and you apply it to asset management, you can find that it has a tremendous amount of utility and value to an asset manager. When you talk about benefits to asset managers, you have to look at the basics of asset management, right? What exactly are these people trying to do, and how does this tool help them achieve those objectives? So, here are a list of asset management basics, and level of repair analysis really does a great job of helping us meet our balance of cost, risk, and performance, and it helps us manage those elements of both physical and intangible assets. Whereas, or not whereas, but in particular, the LORA does a great job of helping us with costs and decision making for physical assets. So if you're an asset manager and you're adhering to these basics, the balance of your cost, risk, performance, and their application to physical assets is a value with the level of repair analysis. So if you're the asset manager, you're constantly asking yourself several questions, right? What type of equipment do I have to manage? What type of environment is it operating in? How long do I need it to function? How long will it function? Should I operate it and maintain it properly? And then what is the remaining economic value of that asset? These are fairly routine questions for an asset manager, and a level of repair analysis can give us the tools and information needed to help answer some of these questions. So asset managers would start with the inventory of their assets. They would have prioritization established. You could use an asset criticality analysis to help you with that. And eventually what you're going to do is you're going to work down the chain to develop an asset management plan, right? And so in that plan, you're going to have to address the maintenance and renewal cycles for assets. And that means you need to plan your resources needed each year to maintain and operate your systems. So the level of repair analysis will, again, help us do that. Once you have this done, you can implement your asset management plan, and then you can review and revise the plan iteratively, moving down the road through the life cycle of the asset. The LORA model or tool gives us the ability to iteratively perform a standard repeatable analysis and continuously improve our processes and our asset management plan as we move through that life cycle. So now that we have that, what do I do with it, right? You've got your typical path of development here for an asset manager, where you're verifying that your asset registry is accurate. You are assessing the condition of assets through their life cycle and determining their remaining useful life. But we get to the point where we have to determine life cycle and renewal costs. And some organizations wait till late in the life cycle to take take action on this. The level of repair analysis will give us the ability to do this from acquisition to disposal of an asset. Okay, and as we confirm the operational requirements across the life cycle, and we constantly adjust asset criticality, we get to this point where we're gonna be trying to optimize operations and maintenance through those efficiencies and effectiveness that I had mentioned in the opening. From there, we can start forecasting our capital costs based on those optimization strategies, and then we can, hand that ball over to the business side of the organization and manage our funding strategy in relation to our asset management plan. So this is kind of what all those things are happening within this critically assessed asset life cycle, right? So once we've assessed the criticality of an asset, it's been acquired, utilized, maintained, eventually we're going to get to renewal and disposal. And so as this loop continues, we'll constantly be performing those asset management functions, and we're going to use this tool, the level of repair analysis, to help us. So for those that are not familiar with what the ISO says about a strategic asset management plan and its relationship to lower level functions, this is an excerpt from 55,002, and it shows how the responsibility for the strategic asset management plan is really kind of held at a sponsor level in the organization at the highest levels, right? And then that comes down to us at the director or manager level through the creation and implementation of the strategic asset management plan. And from there, we develop focused asset management plans for each section or piece of equipment or however your portfolio is established. So the tie of a LORA to your strategic asset management plan cannot be overstated, because the information that comes from the level of repair analysis will feed into and inform the minds that are creating the strategic asset management plan, and then taking it down another level to the asset management plan for each specific asset type. So a lot to chew on there, a lot of precursor discussion, but I needed to give a little bit of background to you about how the LORA integrates with the strategic asset management philosophy, so that you can truly understand as we move forward in the conversation where the value lies in performing the analysis.
That was a lot of information, but I followed it, and hopefully everyone else did too. I'm going to launch our second poll because you're about to kick into a deeper level of LORA, and I want everyone now to tell me just how much they know so that you know just how much to explain. And I'm going to give it just a couple more minutes. Well, not minutes, maybe another 30 seconds or so for everyone to chime in here. We're clicking. And all right, I'm going to close. And there we go. Okay. Back to you, Dr. Marino.
Okay, you ready for me to go ahead and
I
launch?
am. I'm so excited for the case study portion.
Oh yeah, sure. It
Aren't we
is
all?
where it's kind of where the heart of this lies, right?
Yep.
So before we can really understand level of repair analysis, and to give it a little bit more context, we've talked about the asset management kind of perspective on investment and return on investment in the organization and its impact on the life cycle. Let's talk a little bit more about the engineering and logistics engineering side of this, and maybe in some terms that people currently involved in the maintenance community are a little bit more familiar with. As our poll described earlier in the session, we already have several types of familiar analysis in existence, right? And all of these work together. So if you're familiar with the failure mode effect and criticality analysis and its ability to identify potential failures, their impacts, prescribe maintenance and mitigation factors, inform us about triggers and ways to observe failures and how to try and address failure before it occurs, then you understand that that is extremely important in informing the maintenance allocation chart and performing a very detailed maintenance task analysis. There are dependencies in that chain there. Most notably, the maintenance task analysis is going to break out all of the resources and all of the time and all of the tools and everything that are required to perform a maintenance task, okay? So you'll have a list of resources required to do that. Well, the most controversial of resources when it comes to maintenance is almost always the labor force that is performing, right? And that's where the level of repair analysis will help us. Does the cost of maintaining this item and the availability of its resources and the need for special types of talent and the alignment with our existing maintenance policies, when I take all of those things and I put them together based on the maintenance task analysis, do I benefit by repairing the item or replacing the item or simply disposing of the item when it eventually has a corrective maintenance action required to put it back in service? So that's kind of where the LORA closes the loop on this. It gives us that last significant decision about where is it most appropriate to perform this maintenance task when we have a corrective action based on a complete failure of that system. So should we repair it, replace it, or discard it? That's kind of a synopsis here about the logistics engineering analysis loop. So if we look at the way the Coast Guard defines the level of repair analysis, and their definition is very important to the case study because we're doing it on a Coast Guard asset, we want to look at their definition. So it's an analytical methodology used to determine where an item will be replaced, repaired, or discarded based on, and this is important, cost considerations, maintenance capabilities, and operational readiness requirements. So we have constraints and we have a little bit of environmental considerations put on us here in this definition. We must consider cost. We must look at our skills and capabilities, access to tools and resources, and we must also look at what are the operational requirements of the asset. How often and when are we able to perform this maintenance, and how often and when does this piece of equipment need to be operational? So if we're going to use the LORA and use it well, we need it to do things, and the purpose is to analyze maintenance support alternatives. We're going to look at economic and non-economic factors related specifically to this system and equipment, and we're going to use those results to help us develop maintenance plans, which will help us achieve the most effective maintenance support. So you take a level of repair analysis and you break it up into its pieces. What you're going to find is it has 4 main phases of analysis. The first is the non-economic analysis. The second is the economic. Then we're going to perform sensitivity analysis where we change a variable and see how the system interacts, how it reacts to the change. And then we're going to perform decision analysis. And I'm just going to throw a little disclaimer in here. I put an asterisk on it so I wouldn't forget to mention it in the presentation. But anytime you talk about decision analysis and sensitivity analysis together, you should be considering risk as the primary component in your decision, right? So you need to be looking at this from a risk analysis perspective and not just a purely budget or purely operational perspective. We are taking things up a notch and we're putting them into that strategic level of planning where risk is basically a blanket over the entire system. So all of that is said, so we can get to this model that I created to address the level of repair analysis in a more refined way that had been previously prescribed by Handbook 1390 or SAE 1390. Both of those resources give us a recommended framework of performing non-economic, economic, and decision analyses, but they don't really tell you how. And they outline some of the requirements to perform the analysis, but not all of them. So when I was doing my research, I created this framework and continuously built on it as I went through a level of repair analysis in order to make sure it encapsulated all of the pieces and inputs that would be required for us to do this the proper way. In the non-economic analysis, we want to look at things like our maintenance philosophy. What type of training is required to maintain this asset and perform the maintenance that's been prescribed? What type of maintenance data is available to us? What does our supply chain look like? What contracts are in place? When we talk about knowledge resources, do we have prescribed procedures for conducting or executing this corrective maintenance? Is it prescribed by the original equipment manufacturer, or do we have to create it ourselves? You have all of these different options when it comes to your inputs for non-economic analysis. Once we have that information, we really understand the needs of the piece of equipment. okay? And then we can look at the economic piece. And we can say, well, how much does it cost us per hour to maintain this piece of equipment? And that would be our maintenance cost per man hour, okay? Now, in this example, we have two resources, Coast Guard technicians and everyone else. And those everyone else are considered non-Coast Guard technicians. Coast Guard technicians are enlisted members that are active duty members of the Coast Guard's workforce. The Coast Guard owns those bodies. They invest and develop those people. The non-Coast Guard technicians could be OEM contractors or consultants or third-party support entities outside of the service that are brought in on contracts to help with maintenance. So we have that information, those costs related to those resource options. We also have the maintenance tasks themselves and the cost of those items, for parts and consumables and all of the material costs and handling and everything that goes into getting a part onto the asset. And we can take all of that, compile it, and look at the comparison between different resources. If I compare resource 1 versus resource 2, what are my expected max costs, minimum costs, average costs, right? How much? And I can do that by maintenance task. So I can determine if one task has more priority for funding than another. And we may choose to mix resources based on the various costs amongst the resources, okay? When all of that is done, we want to perform a sensitivity analysis by changing the most impactful variables. In this case, we'll use a one-way sensitivity analysis where we only change one variable, one input to see how the system responds, just to kind of keep it clean. And then you would perform a decision analysis after that, which would ultimately update your organization's maintenance philosophy or program approach. And then you could confirm or update your logistics requirements. Do we need to procure training or revise the training that we already have? Do we need to develop more maintenance team resources? Do we need more or less people? And do we need to establish any more formal agreements through contracts? So this is kind of like the big piece of the pie to consume. And moving forward, you'll see how it's applied in our case study.
All right, so I gotta butt in because
Yes,
there's
ma'am.
so much information on that diagram. If you'll go back to it
Okay.
for just a sec.
Mm-hmm.
So in one diagram, you have put the entire flow for decision making to determine what level of maintenance to apply to an asset, where you've started with your infrastructure, and then you've gone into your costs, and then you've gone into sensitivity and risk. And I feel like a lot of this information exists but isn't necessarily documented, and it isn't put into a communicated flow. Would that be correct?
Yes, ma'am. Absolutely. Yeah.
Okay.
No, most people have this information floating about, or it's easily attainable. It just hasn't been organized and put together and looked at in one holistic form of analysis.
And do you communicate this flow up and down the food chain? Is this something that everyone's aware of?
Yes, in the end, what you would ultimately want to produce is all of the data that comes out of the level of repair analysis, but you would also want to accompany that with a report,
Mm-hmm.
which takes all of this information or data, sorry, converts it into digestible, analyzed information, and then makes recommendations in the report as to how you should make decisions moving forward for your program. And all of this
Okay.
would be captured in that report.
Okay. All right. Well, let's
Yes,
see
ma'am.
the case study play out.
Okay. So I'll give you a brief summary of what we did before we talk about the results. So the Coast Guard is responsible for adequately aligning its maintenance requirements with all of its available resources throughout a vessel's life cycle, much like a commercial organization would be responsible for doing the same for its resources. Unfortunately, um, the estimates that we had for performing corrective maintenance on some of our most expensive equipment on our newest assets failed to prescribe any optimal balance for between our internal and external resources. We didn't have a good idea of how much we should depend on Coast Guard or non-Coast Guard technicians to basically execute our corrective maintenance on these very expensive, very complex assets. Okay, so that was the problem statement and the motivation for pursuing this particular topic and application. So if you look back through the reasons for the level of repair analysis and the way the acquisition processes are structured in the U.S. Coast Guard, they require that you perform a level of repair analysis to help inform those decisions. So the solution would be to perform a level of repair analysis on an iterative basis. And I wanted to add some elements of a business case analysis to it so that we could measure and control our costs and balance our repair resources. I didn't want something that just said, you're going to want to do this because numbers told you to. A business case analysis would then take it and say, well, is this feasible for us, right? And if it is, or it isn't, what is the gap between what should be and what can be, right? We apply this to our maintenance costs and resources so that we can develop that new maintenance philosophy and adjust our resources. So one, I had to develop a LORA model with which I was going to perform the analysis, right? So, and I wanted it to be informed by activity-based cost management. And I think this is important for maintainers because maintainers don't look at a piece of equipment and say, what does it cost to perform maintenance and surround that part with costs? What they do is they look at how much does it cost me and how much time is required and what resources are needed to perform this task. And an activity-based cost management approach gives us the ability to focus on the task and not just a part. Okay, so then we develop procedures to execute the analysis, which I've shared, and then we actually perform the analysis. And I chose the National Security Cutter, its propulsion engine set, and the various options for resources that we had available to us. So a little bit of information about how the Coast Guard views maintenance so that you can understand why this is important. Well, the Coast Guard has planned, unplanned, and new work considered as their maintenance types on large vessels. We split our maintenance into what's called a bi-level maintenance model, where organizational maintenance is executed by the ship's crew. Ships are known as cutters. And everything else that's not prescribed to the crew is prescribed to a depot maintenance resource. So depot maintenance is basically anything that's not handled by the crew. And in your depot maintenance, you have, as I stated earlier, you have Coast Guard resources, which are called maintenance augmentation teams, and you have contracted support, and then you have other various types of industrial support as well. So we had to work with a few assumptions in the research. Since economic analysis is so important, we had to establish some composite labor rates so that we could match apples to apples when we talked about rates for Coast Guard technicians against non-Coast Guard technicians. And so I had to create these rates based on pay scales and the standard personnel cost that the Coast Guard identifies. If you are in an organization, you would take the standard personnel cost for your people, right, their hourly rates, and you would want to develop those so that they aligned equally with, or as close to as possible, with your other resource options. This way you're not, fudging the numbers by basically not looking at the total cost. I had to assume how many hours is someone going to work a year on maintenance tasks alone. And fortunately for me, the Coast Guard already prescribes a number, and that was the annual work hours of 1579 a year. And that takes into account the fact that people are otherwise doing training, otherwise in medical appointments, on leave, and doing routine administrative type tasks not related to maintenance. And then, of course, we had to build overhead rates because the military doesn't account for overhead the same way per hour as a non-military organization would, so I had to create those. So performing the non-economic analysis informs our initial support decisions, and it helps us determine which economic factors to look at. And so I had to look at all the different elements listed here as non-economic analysis, and when we extracted all the training needs, how proficient our staff are, the availability of our data, the availability of our resources, we were able to load up our non-economic analysis. The next key important piece was, what do our maintenance procedures look like? Okay, and the maintenance type, title, and task data became important. The most critical piece was the task data. How many hours is it going to take to do this? How many technicians will it take? And how long is that team going to be working on that corrective maintenance action? Okay. Then we take the types of technicians, assign them to the appropriate level, and the appropriate quantity of technicians per task. And when you load it all into your database, it'll look a little like this. You have a task, which is under title, and then you have the hours per component under task data, the number of technicians required for that task, and its total team labor hours. And then you can divide those hours amongst all of the different levels of technicians needed. And what this does next for you is it gives you the ability to determine the labor cost per hour for each of your different resource types. In our case, we had the labor per hour for Coast Guard and total labor for Coast Guard, and those same numbers for non-Coast Guard and a blended team.
Can
And
you
I'll
go back
explain.
to the previous chart just for a minute because there's a
Mhm.
lot here and I want to make sure that people are tracking with you.
Yes,
So if
ma'am.
you'll repeat one more time what the key columns are here.
Okay. So the main columns here to pay attention to are the title of the task, right? Um, the hours per component, the number of technicians required to execute that task in that time frame, and then how many team hours are involved. Okay, so now I know how long the team is on site, not just each individual. And then what I can do is I can break up each of the individual labor hours that that team is on site working on that component based on the maintenance task description, right? In the maintenance task analysis, it would say you need one advanced technician and one basic technician. Then I would
Got
be
it.
able to divide that up amongst those resources.
Thank you.
Okay. Yes, ma'am. All right. So then, as I was saying here, you've got your different resources and their labor rate per hour, and then their total labor rate when you aggregate the costs. And then we have the second half. Now, these are the same tasks you saw earlier. You can see that the labor rates per Coast Guard technician type are listed there by dollar amount now because we took the hours and the rate per hour of each of those technicians. And now what we do is we have the contracted and non-contracted labor costs, right? So I've got Coast Guard labor rates, I've got non-Coast Guard labor rates, and I've got blended team labor rates. Now, a blended team would be a blend of the Coast Guard and non-Coast Guard resources. So it'd be a blend of your team and an OEM. And that is a very, very powerful approach to take if you have a blended team, because it allows you to bring in an OEM level technician, right, which reduces the knowledge risk, the risk of having the incorrect level of proficiency on site, and it increases exposure for your staff to an expert. So they're learning the whole time they're working with that person. So the blended team is a very good option. Now at the bottom, you can see that we sum the total cost of each resource to conduct every one of these maintenance tasks. Okay, so if they performed every one of those maintenance tasks once, you'd have a total program execution cost of X per resource.
This is a lot and I'm tracking and it makes great sense. And I'm thinking back to the master diagram when we go from non-economic to economic and then I'm assuming to risk analysis. This is the economic analysis piece here.
Yes, ma'am.
Fantastic.
Absolutely. Yep. So those aggregated numbers are the ones listed here. I mean, that's basically what you're going to want to know. Your program sponsors aren't going to want to know how much it costs to remove a cylinder head from an engine. They want to know how much the whole resource is going to cost them. So the Coast Guard team would cost me $21,997 to perform all these tasks once. You can see if we went strictly OEM or strictly commercial, it would be well over that at 57,000. And then if we use a blend, we get 32,000. So now we have to start making decisions about these three resources. Which is best? Which one should we adopt? Correct? So a few things we have to make everyone aware of is that we can't consider sunk costs in these totals, okay? Our special tools were acquired with separate money in our acquisition phase, so I couldn't count those as a cost, okay? Our technical information was also acquired first during acquisitions, so I couldn't consider that cost in this analysis. And all of our maintenance facilities were already in place before the teams were assigned. So all of those sunk costs must be removed from these numbers. That's why you'll notice they're a little lower than you may expect. Also, you have things called neutral costs. If your supply chain for that part consists of one vendor, okay, because they're a sole source provider, that's technically a neutral cost because it doesn't cost your resource any more than it would cost for you to pay the contractor to bring that part in. It becomes a neutral cost. If there's a difference between those two, it's no longer neutral. So you just have to kind of make sure that you're talking about the right numbers when you do this. If it costs you the same amount as it costs them, it's a wash.
Is there
Okay.
a risk,
Mm-hmm.
Lucas, in showing all three of those numbers to management? Because what if they go for the lowest dollar?
There's an absolute risk in that, and that's why you need to remind them, look, you're asking me to do a very detailed analysis so that we don't make a decision based off of one number, right?
Got
We're
it.
using all of these different inputs and variables so that we can consider this great decision with all of these different inputs and not just a bottom line financial number.
Okay,
Absolutely, that's an excellent question. Lowest price shouldn't always win, right?
great.
Okay. Yeah, because there are risks associated with the lowest price in many aspects. So what I did was I took that data, okay, of every one of those costs for every one of those tasks, and I put it in a data representation or a bar chart so that when you show it to your decision makers, they can see and not just try and digest 20 different numbers, but they can see on a chart the comparison between resources and between different tasks. If you look at each of these individual tasks, you'll see 3 bars, one for Coast Guard, one non-Coast Guard, and one blended team bar for each task. And I can visually depict what the delta is between those resources. Some of these jump right off the page at you as, wow, one resource is clearly a much different cost than another, and others are very close to each other and may not require as much scrutiny, right?
This is an awesome decision-making tool. I mean, what would you advise if you were talking to your sponsors here? What would you advise?
If I was giving a presentation on this information, I would say this is getting us to the doorstep of making decisions. We need to understand that not all tasks are created equally and that not all resources perform equally on every task. Some of these tasks, we should be very targeted on how we resource them, right? So one blanket decision about just choosing the lowest price option is never going to be the right answer because we have such variation between resources as we move across the different tasks. So a wise thing to
Fantastic.
do, yeah, would be to focus, on multiple decisions to maximize efficiency and effectiveness.
Great. Thank you.
Yes, ma'am. So this is super like high level, not very deep type of questions, but I try to whittle things down to the simplest form when it comes to decision and risk. If you can ask yourself a few questions while you're going through the more detailed decision analysis and risk analysis, and kind of keep these in mind, you'll be better off as a person leading this analysis, okay? Because really, you don't want to lose sight of the real reason you're there, and you don't want to lose sight of the impactful questions that exist. A few of them are listed here, okay? Um, it's pretty simple that if the cost of maintenance isn't acceptable, okay, we still have a problem we need to address. Okay, if the support elements are in place to ensure success, then we need to make sure we're pointing to them and that we're paying attention to them. Is the proposed maintenance appropriately funded? Just because you're funded doesn't mean it's the right cost, right? So there's difference in these questions for a reason. We want to guide our decision making by establishing some core questions that we should be asking ourselves as we perform the analysis. Is this piece of equipment in the acquisition phase? If it is, it's a way different perspective on the life cycle position of this asset than say if it were in sustainment or close to being disposed of. Um, do our non Coast Guard resources even have enough capacity if we were to turn them on and say we want you to do all this work? Okay, we don't control their schedule. Do they have the capacity? And so on and so forth. And so you can see the importance of kind of keeping these core questions developed and on the front of your brain as you're going through your analyses. And you can build your decision making and your risk analysis off of many of these key objectives and many of these key points to keep in mind. So let's look at what actually happened when we performed a one-way sensitivity analysis on our 3 resources. Okay, so as a reminder, our blue line across the chart is our Coast Guard team. Our gray line is our blended team of Coast Guard and non-Coast Guard resources, and our orange is our contract only, right, option. That's just strictly going with a non-Coast Guard entity or non-organizational entity. What I found in studying over a year's worth of depot maintenance performance on a like asset, right, on a similar system with the same technicians, was that the most unstable variable in all of maintenance execution data was the duration that it took to complete a task. So with duration being the most unstable variable, I felt it had the greatest impact on the total cost of a maintenance task. So I found the variation, and it swung anywhere from just faster than prescribed, which would put us near the 0.8 on the bottom scale there, on the bottom axis. One would be the exact amount of time that was prescribed for the task. And as we move further forward, we find that we're moving in multiples, right? 2 would be 2 hours instead of 1 hour to complete the task. 3 would be 3 hours to complete the task instead of 1 hour. And you can see what happens to the cost of your resources as that time period gets longer and longer. The cost delta opens and opens. Okay, so if your proficiency is low, your risk is high, right, of experiencing extended durations. So you have to consider where in the life cycle you are, how proficient are your technicians, what's the max cost, what's my break even. I put break even points on there and dotted lines that move from left to right in dash blue or dash yellow. So you can see where the break even point is between the Coast Guard team and everyone else, or the blended team and everyone else. And you can try and cap where you're willing to invest your time based on durations. So this is a very powerful way to change a variable in your analysis and see how the system reacts.
Once again, it is just brilliant that you have been able to document something that is present in people's brains. How skilled is my team? Can they do this work? How much time will it take them to do the work? What's the level of fail risk? But that you've been able to document it, and in numeric and cost data format, that's a very convincing way to communicate this.
Yes, ma'am. Yes, ma'am. Thank you so much. And I think the big point to take away from here is, as you mentioned earlier, and I think that was an excellent point, you don't want to make a decision solely off of this chart, right? But you do want to understand that this chart tells you the risk associated with each asset, right? Or each resource, sorry. It seems that I have more control over cost risk if I choose the blended team or the Coast Guard team. And when I compare the blended team to the Coast Guard team, it doesn't seem like it's that much of a jump, considering the trade-off. So if I were informing my leadership, I'd say, look, this blended team gives us the best bang for the buck. I mean, look how low our risk is compared to solely relying on an OEM contractor or an outside team, right, cost-wise. But look how close it is to our own resource. We're not having to invest significant amounts of money to gain that reduction in risk or gain that confidence level of having an expert on site. So, okay, now this timeline, you need to kind of think flexibly about this timeline. This timeline is catered specifically to a very large asset in a very large acquisition program, and not your traditional purchase of equipment at a smaller level. It should not take you 10 years to get this in place for smaller assets. So you have to cater this timeline to your organization's culture and its way of doing business. That's where the non-economic analysis can help you really inform your timeline. With the Coast Guard assets, we figured it would take up to 5 years for them to obtain OEM support through technical information, special tools, a central inventory of parts. They had to develop a maintenance staff team. They had to develop the maintenance procedure cards themselves so we know what work to do. We had 5 years to basically get all of our maintenance foundation established. In the second 5-year term, we would be able to renew our contracted support and stand up a blended team. We'd be able to conduct a front-end analysis on our training needs, and we'd be able to start training our people toward the latter half of that time period. We'd be able to start giving Coast Guard technicians advanced level training so that in the next 10 years and further, we would be able to exploit those talents and take advantage of those investments and continuously improve the sustainment of our depot maintenance activities. So this was a timeline that was custom tailored to the Coast Guard, but you could take this same approach and apply it to your organization so that you're not just talking about what you should do, but now you're showing a way to move forward through the life cycle of the asset and actually execute a plan. Okay, so a little bit of synopsis here, kind of wrap up. What we recommended to the Coast Guard was a blend of both active duty and non-active duty technicians so they could reduce their risk. It gave them the ability to have surge staffing in the event of a large volume of maintenance requirements. And it also gave us the ability, and this was most important, to maintain quality, because you just spent millions of dollars on these assets. You need to make sure you're performing quality maintenance procedures, okay? We recommended a team of 2 advanced OEM type technicians and 5 Coast Guard basic technicians so that we could take some of the labor costs off the back of the OEM and give our Coast Guard technicians some proficiency. And then we had to recognize some limitations, okay? We had a dependence on valid maintenance task data not being readily available because it was so early in the life cycle of the assets. We had to create a lot of that data. Okay, we had a limited exposure to level of repair analysis. So people weren't very familiar with what we were trying to do and what questions we were asking and where we were going with all of this. We also had a lack of industry guidance because there really is no definitive reference on how to complete a level of repair analysis. So how does this benefit you? Okay, because that's kind of like, what's the bang for the buck here, right? Why did I just sit through all this, and what am I gonna do with this? Well, if you take the LORA framework that I've presented to you, you'll have something to standardize the way you're completing your analysis, and you'll have a very repeatable process for doing so. You can create standard forms based off of that model that ask specific questions every single time you do this so that you have a consistent analysis. And I create some of those forms and publish them in my research paper, and they'll also be included in the book. This also gives us that ability to look at the cost of a task, okay, and not just the cost of a part. I wanted to make this relevant to the maintenance team. How much does it cost us to do an action? Because the action is what's driving our workload, okay? So that gave us the ability to approach maintenance programs through that activity-based cost management approach. And it also gave us the ability to reveal some potentially unseen relationships between our maintenance tasks and our costs, okay? And that was one thing that the activity-based management approach really gave us. And that is all I have to pass on LORA.
That is fantastic. There was a lot of information, and I'm so glad we have some time for Q&A here.
Yes, ma'am.
Are you willing for folks to contact you directly? Is that okay?
Yes, ma'am. Absolutely. That's my email address at BMT. And I welcome anyone to reach out. If they just want to talk about level of repair analysis, that's great. If they want to talk to us about how we perform level of repair analysis, that's also great.
I would also suggest to everyone that they follow you on LinkedIn because your book is coming out and there's going to be more information about LORA through that, right?
Yes, absolutely.
Very good. Okay. Well, you have some fans on the Q&A tool. Everyone who's on the call, you are welcome to type in more questions at this point. I'm not going to promise that we're going to get to all of them, but we will follow up afterward with you specifically and also through some Q&A post on the blog for any questions we don't have time to answer. And I don't usually do this, but I'm going to specifically call out Commander Pravda, who is your #1 fan and has lots of questions for you. Commander Pravda, we're not going to get to all of your questions, but I'm going to kind of cherry pick here a couple of them, and we're going to get started. Okay, Lucas?
Yes, ma'am.
All right, here's the first question. In facility planning and design, there are often questions over how much is too much or too little data to include in BIM, Building Information Modeling, digital asset creation. How can later stage users of the data, facility maintenance, provide guidelines to early stage digital planning to create a life cycle of the framework to improve maintenance support, right?
Yeah, excellent question.
Yeah.
My background is in systems engineering, like, academic background, and I tie everything to requirements. Everything. right? Like my brain just goes to requirements
Yeah,
automatically. So when you
yeah.
ask that question, really what you're saying is, what requirements do I need to establish for those early users or implementers so that later on we have the right information in the system, right?
Mm-hmm.
And
Mm-hmm.
you're going to define those requirements about based on their usefulness. What information do you need to perform the tasks and planning elements that you need to execute to support this asset? So the first thing to do is decide what data and information you absolutely need, and then make that a firm input to the process as early in the process as possible. So if I'm understanding the questions properly, I think you just have to define the requirement for information, and that drives some purpose into the request. It's not just, hey, I need you to give me this information because I might need it later on. Okay,
Mm-hmm.
you're actually
Mm-hmm.
tying it to some requirement that is going to impact decision making down the road.
Mm-hmm.
So if it doesn't have value, it will quickly get lost and it won't be respected. And I don't know if
Right.
that, exactly addressed it, but
No, no, it's very true. It's very true. Can a human resource rating, like a 1 to 5 star, be used to provide estimates of knowledge workers and costs?
uh, if I think that's going to be really hard to do.
Okay.
Okay, because I don't think you can just tie one metric or one measurement to those multiple variables and get a fair shake out of it unless you get to that one number through other numbers, right? Where
Mm-hmm.
that is the average of some other inputs, right? Like where you assess a person or a process on multiple dimensions, and then you convert those multiple data points into one some number or one mean number, and then you use that as like a strength rating for that thing. I think you could
Mm-hmm.
definitely do that. So
Mm-hmm.
the devil's in the details here. Each of those individual criteria that you established and weighted earlier, right, to come up with that one number, those are what actually support that one number. So the value of performing that to getting to that one number lies in how you establish the criteria in those earlier factors,
Mm-hmm.
right?
Mm-hmm.
So if
Okay.
you can do that well, that last number means something. If you don't do that well, the last number is garbage, right?
Yeah. Yeah.
Right? It'll never actually reflect reality. So you'll go to use
Yeah.
it and it won't be usable, right?
Yeah. I have a question from David Reynolds here. Have you experimented with multivariate risk analysis? So capabilities available in Excel add-ons such as at risk, interactive, iterative capabilities like these that can help explore risk. So other risk tools.
Yes, yes, absolutely. Multivariate analysis is extremely powerful, and it provides you an extraordinary way to address risk across all these different dimensions of risk, right?
Yeah.
So yes, absolutely. When you talk about really doing a true risk analysis, or when you dive into really doing decision analysis, you must consider multivariate risk analysis. You cannot simply base your decisions off of a single variable. So yes, the short answer is yes, and I highly encourage you to do so. Especially if you're comfortable with doing that. The danger is you're handing the keys to somebody,
Yeah.
hopefully that knows what they're doing,
Mm-hmm.
because when you do multivariate analysis, it can go in so many different directions based on how well you manage it.
Great. And great question and great answer. Thank you.
Yes, ma'am.
Here's another question from Dimitrio Bricata. Apologies if I mispronounced your name. He asks, is LoRa already developed for CMMS systems, or is it just an Excel-based solution?
It is not just Excel based. There are some software available to help you. I say help you because they won't do the full LoRa for you. They can help you perform a LoRa. One of the tools that's commercially available is called SlickWave, right?
Ooh, okay.
Um, there are a few other items out there. They're coming along. The Department of Defense uses a system called Compass, right, which is
Mm-hmm.
basically a partner to their other larger logistics system, PowerLog J2.
Mm-hmm.
And those work hand in hand. But what I found with software, for at least the software I've been exposed to for LoRa, is that it helps you organize and compute and digest the data, but
Mm-hmm.
it does
Mm-hmm.
very little to help you discuss, obviously, uh,
Yeah.
the
Yeah.
decisions, right? And so you're going to, it's not like a one-stop solution where you buy some software and it does your LoRa for you. You're going to have to perform the non-economic analysis
Mm-hmm.
in a
Mm-hmm.
very concentrated way so that you know that the
Mm-hmm.
decisions you're making based off the economic analysis makes sense, and that you're actually acquiring the proper economic inputs, not just what the system tells you to put in.
Right. Okay, real quickly, um, how can facility management workflows like this help empower state, local, municipal, or education facility management to help citizens' bottom line with your kind of precision?
Okay. Well, I'm of the mind that the more you know about your stuff and
Yeah,
the more you can show that to other people, the more empowered you become,
right,
right? So you can use this as basically leverage to demonstrate your competence about your budget, about your asset management processes, about your maintenance programming. All of those things are supported by any type of vigorous analysis that shows you A, know what you're talking about, you B, you have done the work to justify the request that you're making
right.
or the claims that you're making or the decisions that you're making. So this can really empower decision makers to have more confidence in the things that they're doing externally to bring that relevance or weight to your organization.
Awesome. Can you forward your slide deck by just one for me? And that means going back to a different click tool here.
You need me to go forward?
Yes.
Okay, there you
There we
go.
go. All right. So we are just about out of time, but I want to encourage everybody on the line to look up Accelerate 19. If you go to flukeexcelix.com or excelix.com, excuse me, you'll find information about the Accelerate 19 conference where we're going to have a lot of expert level conversations about asset management, and you are all invited very much. It's a really good, very hands-on focused session. And then if you will click forward one more time for me.
That's not moving. Give me 1 second. There we go. All right,
There we
now it's moving.
go. There we go.
Mhm.
So we have these webinars about twice a month, and as you have seen, we always welcome a lot of Q&A, and we try to have some of the leading practitioners in the industry come and share their knowledge. So please feel free, be welcomed back to further webinars in this series. And then one more, click forward, please. There we go. So anyone who completes the survey after I close the webinar will receive a copy of Dr. Marino's slides. And we have all of your questions you've answered. You're welcome to contact him directly. Follow him on LinkedIn so you can find out more about the book that's coming out with all of this wonderful LoRa knowledge in it. And we look forward to hearing from you all soon. So thank you so much, everyone. Thank you in particular, Dr. Lucas. This was fantastic. So much
Thank you.
information, and it's so useful. Thank you, thank you, thank you.
Thank you for having me on. Appreciate
Absolutely.
it. Mhm.
All right, everybody, have a great day, and we'll see you next time.